All right, so I just wanted to go through a couple more examples of these to help you get a better feel for it. I'm actually going to do this one, which should be very straightforward for you. I'm going to do it a little bit differently to give you another option of ways to think about these. Um, so I'm going to give you a more of a straightforward approach, I think. But the setup is exactly the same. So what we're going to do is start off by factoring and write factors of -6 that add to give you +1. And since we have non-repeating linear factors, we just set it up like this. And, so far exactly the same. The next step is also exactly the same. We're going to end up multiplying through by the factors of our original fraction so that they cancel and we have no more denominators left. So I'm going to multiply through by x plus 3 and x minus 2. And again, the idea is that when we're being forced to distribute here, and when we do that on the left-hand side of the equation, the two terms will, or I'm sorry, the two factors in the denominator will cancel and we'll be left with a 5. And then when we distribute to the first term on the left-hand side, the x plus 3's will cancel, and we'll be left with a times x minus 2. And then for the same reason, we'll have b times x plus 5. X plus 3. So now, everything's the same as what I showed you before. And if you were fine with making up numbers for x, like you'd make up 2 here and solve for b, right? You put a 2 here and a 2 here and then solve for b. And then a -3 here and solve for a, then go ahead and do it that way. But here's just another thing to think about that will, maybe will help you later on. So I'm going to actually distribute the a and then distribute the b. And then I'm going to get like terms next to each other. And really, I'm just looking at these two as like terms. And so now what I'm going to do is I'm going to rewrite this left-hand side just slightly differently. And then I'll explain why I did that. But before I explain, I'm going to also factor out an x right here. So I've added this little empty, non-existent term. And so what we're saying here is that if this is an equation, that means that the left-hand side and the right-hand side are the same. And you notice what I just did here was I set up this term with an x. Well, that corresponds with this 0x. And what I'm going to say is like if these two sides are equal, then that means a plus b has to be 0. And then the 5 is going to be equal to everything else without a variable. And so then why this might be better for you is that, this is very straightforward. And now all we're going to do, there's no making up numbers or anything like that. Now we can just do a system of equations. And you can, you're welcome to do substitution or elimination. Or if you know how to do it on the graphing calculator, you can do that as well. But what I'm going to do is elimination here. So I'm going to multiply this one by 2 so that we have 2a plus 2b equals 0. And then that means 5b equals 5. And so now we know that b is 1. And so now we can come back over here and solve for a. Now remember, we have to write this answer in a specific way, so let's go back up and check what the factors are. So now we're saying our answer is negative 1 over x plus 3 plus 1 over x minus 2. So that's just another way to think about it. You can, ignore this way for now. It will be useful here on some more of the more advanced problems. But you can always just do the old way as well. Okay, so this will be the only other example I do for you guys here. I think this will be good enough for you to figure out what's going on. You don't have to do 27, so this is, this is in the book though. The beginning is the same, we got to factor the denominator, but if you look closely, it's already factored because there is no factors of positive 3 that can add to give you negative 2. And so this is already factored, and so then I'm just going to go straight into the setup, which would be right, so the first one, x plus 1, is a linear factor. And then the second factor is a quadratic. And so then that's how we have it set up like this. And again, it's the same as before. We're going to multiply through by these two factors. They'll cancel here, and things will end up canceling as we go. So that's going to look like x squared plus 5, and then a times x squared minus 2x plus 3 plus bx plus c and x plus 1. So I think these are much easier if you grasp the concept on that previous problem. I think these it's easier to just deal with a system of equations on this. So I'm going to distribute the a, I'm going to FOIL all of this, and then rearrange some things. So be careful on the FOIL. And so I'm going to use this idea again from the previous problem. I'm going to add in a 0x here, since we're missing that from this side. And now I'm going to rearrange, right? We have ax squared plus bx squared. So I got these. And now I'm going to do the x's. So now we have negative 2ax plus bx plus cx. So for these. And then we're finally just left with a plus 3a plus c. And now I'm going to factor out the common factor in these two different groups of terms. So I'm going to leave that. And when we factor out the x squared here, we get that. And then now I'm going to factor out an x here. And then we're just going to leave the rest of this alone. And now we have the same idea as we did before, where we have two sides that must be equal, and we've rearranged their terms so that we can just set them up with the terms on the left. So coefficient of 1, coefficient of 0, and then 5. So we have 3 different equations that we can get. So a plus b equals 1. And we have negative 2a plus b plus c equals 0. and 3a plus c equals 5. And now we can do, you got to do elimination, or if you remember how to do it on the graphing calculator, you're welcome to do that, and that would be the easiest way. That's how I would do this one if I wasn't showing you how to do it, and if I had a graphing calculator on me, which I don't. So we're going to have to do some kind of elimination. Just quick refresher. We already have eliminated C here, so then we can use these two to eliminate C. And then that'll make our process fairly quick. So then I'm going to multiply this one by -1. And so then we have -3a, negative c, and -5. And so now when we add that down, we have -5a plus b equals -5. And then I'm going to take that information and eliminate it with our first equation over there by multiplying by a -1. So then we have 5a minus b equals 5. When we get down, we have 6a equaling 6. So now we know that a equals 1. I'm going to come back over here to our furthest right equation. So then we have 3 times 1 plus c equals 5. So 5 minus 3 is c is 2. And we can go back and find b as well. So -5 times 1. All right, and so then we add 5 to both sides and we get b equals 0. So, again, you can use it on the graphing calculator, but we do want to write this in the correct way. So, we go back up top to see what we had. X plus 1. Try it again. So then what we're saying is our answer would be 1 over x plus 1 plus, I'll write it like this right now. The b is 0. Now, of course, that's not how you're going to leave it, but and so then we're saying that this is our partial fractions. So I hope that helps you out a little bit.